Hello again. It's been a little bit since I posted anything here. So today we'll be taking a look at Azure Load Balancers. So we'll be taking a look at how to leverage Azure Load Balancer for your virtual machines living in Azure and for various different use cases. So you may be asking, what is an Azure Load Balancer? So the Azure Load Balancer is you think of it as a kind of a managed service that will allow you to balance load internally, so within your virtual network in Azure, or even externally or publicly out on the internet. So you can have a endpoint out on the internet that will balance inbound traffic to various different virtual machines within your Azure network. So there's essentially two different versions. So they have a kind of a basic SKU as well as the standard SKU. There's a large number of differences between the two. They kind of have that published out on their website what the differences are. For the purposes of what I'm going to show today, we'll be using the basic Azure Load Balancer, and because one of the things I like about that one is that it is currently free, so there's no charge for leveraging that particular service. So I'm going to go that route for this demo, and then for my use cases for what I'm actually using it for, it works perfectly fine. There's probably some other enhancements that I can get by using the standard, but for now, it's just as I'm learning how to use these things, I'm going with the basic. So let's go ahead and get started. So as you can see here, we're here in the Azure portal, and I'm currently looking at my virtual machine. So I have quite a few number of various different virtual machines in my environment. They're in various different locations, there's various different size, and they're hosting various different roles. So since I'm using the basic SKU for Azure Load Balancer, there are some requirements or prereqs that you kind of have to fulfill in order to get it to behave the way that you want. So one of those things is that when you're using the basic, you kind of have some restrictions as far as what type of VMs and requirements for the VMs on how they need to be prepared so you can use it within the load balancer. So you have an option where you can point to like a single specific VM. You can also point to a VM that's part of or multiple VMs that's part of a particular availability set, or you can point to VMs that are part of a scale set, a virtual machine scale set within Azure. So those are kind of your three basic options as far as that. So the key is, so say if you're trying to load balance a website, for example, and each one of those websites are there. Well, the same website is hosted on multiple virtual machines within your environment. You will need to deploy those virtual machines in availability set at deployment time. Gotta stress that it has to be at deployment time, because if you don't do that choice initially, there's no way to kind of like flip a switch in Azure and have a VM later be part of availability set. You actually have to redeploy it out and then connect it up to be part of an availability set. So yeah, just kind of want to stress that because that's kind of some snags as I was playing around with this that I continually ran into. Is like, oh nope, I can't do this because I didn't deploy any of this stuff in availability sets initially. Even though the idea when I deploy them is that they're kind of servers that are backing up each other for the various different cases. So I digress. Just kind of went on a big tangent there on that. But so what we're looking at here, I have two SCOM or Operation Manager VMs. So both of these are management servers, and that's kind of one of the apps that I'm going to be load balancing publicly out on the internet for the web console that's hosted on those servers. So that I give admins access over the internet to the SCOM console, even with those virtual machines that are living in Azure behind my private network. All right, so there's a couple prep works. So as I mentioned, they do need to be deployed within the availability set. So I've already taken care of that. I have two VMs here, SCOM-SAC1 and SCOM-SAC2. They're currently not running, and they are both part of a SCOM-SAC-MS availability set. So that's kind of prerequisite one that I need to have. So since I already have my virtual machines prepped in there, so now what I need to do, I can go to, normally I already have tagged on my dashboards on my favorites here, but if you don't see load balancer, what you can do, you can go up to all services over here on the left hand side. You go ahead and click on that. So once that loads, you can see load balancers here. And if you wanted to pin this to your favorites, all you have to do is click the little star here, and then that'll pin it on the left hand side to your favorites. So I'm going to go ahead and jump over into load balancers. Give that a moment to load. So once that comes up, you'll get presented with, normally it will be nothing here, this will be blank. I've already created several load balancer, and I gave them a name, so I created an internal one, and then I also created 2 external ones. So for the purpose of what we're doing here, I created this public one named public-scom-sac. So let's just kind of go through the exercise of actually creating one so you can see what that experience is like. So what you do, you just go ahead and click add. System is pretty slow today. I'm sure what the deal with that is. Alright, so once that comes up, you got to give it a name. So let's say if I name this sample public. Actually, let's do ALB-sample public. All right, and then you choose if you want to do a internal or public load balancer. So again, the difference between here is that public versus internal is kind of outlined there. But the gist of it is that if you're using a public load balancer, that's traffic coming out from the internet inbound to your virtual machines within your Azure network. And then if you're doing an internal load balancer, that's from virtual machines or your own desktop or whatever that's maybe part of your virtual network or is routable to your virtual network, hitting a particular IP within that virtual network, and then that IP is forwarding that traffic to several virtual machines that lives behind that IP address. All right, so again, I'm going to do public, and also we'll do basic as I mentioned. So you have the 2 options, basic and standard, and then you have an option of getting you have to get a public IP address. So if you already have IP addresses assigned that you have requested in Azure that you aren't using, you can use existing, or you can have it create a new IP address and assign that to your public load balancer. So in my case, I'm just gonna allow it to create a new one. We got to give it a name again. All right, so I have IP. Then you have option to say if you want it to be dynamic or static. I'll just leave it at dynamic for now. You do also have the option of getting an IPv6 address. For my purposes, I'm not going to get an IPv6 address. And then down here, you got to specify what subscription you want to be a part of. So if you have multiple subscriptions, they should be visible here in the dropdown. So I'm just going to leave it on the default one there. Then you have to give it, put it into a particular resource group. So you can either create a new one or select existing one. So again, I'm going to create me a new one. And then finally, you got to say the location where you want that load balancer to live. So if your virtual machine is in East US, for example, that's probably where you want to put your load balancer associated with that location. So wherever that is, you kind of want to match that up so it's nearby your virtual machines. And then you just go ahead and hit create. So that'll dispatch out to the Azure infrastructure. Go ahead and build that for you. So the validation was successful, so that job will be dispatched out. So that'll take a little bit to create. I think mine normally took maybe a minute or so, but we'll give it a and be back once it finishes. So didn't take actually very long at all. So that took a couple seconds. I think the first time I created one, it took maybe about a minute, maybe 30 seconds or so. But that happened pretty fast. So now we have a new load balancer here that we can go and configure now. So I'm going to go ahead and click on that. So once you click on that, that'll bring you over to this overview page. So on this overview page, you see that there's different things defined. So I can see my resource group name, the location, description, various different subscription ID, the SKU that it is, public IP address associated with it, at least the display name, and then also if there's any particular rules, backend pools, health probe, etc. that's associated with that. So since this is a brand new one, I have nothing defined here, so I need to go and configure these things. So if I go over to front end IP configuration, go ahead and click on that. I can see that what's configured, so I only currently have a single IP address, but I could add additional ones if I needed, and different IP address could be going to various different or associated with various different things. All right, so if I go to backend pools, this is where I define the virtual machines that I want to have associated with whatever I'm trying to load balance. All right, so in this case, I'm going to go ahead and hit add. And I'm gonna give it a name. Forget what I was naming this. Public, say SCOM. Let's see. Okay, so I gave it a name, and then IP version IPv4 or IPv6. I'm going to use IPv4, and then I gotta click it down to say what I want to associate it with. So as I mentioned earlier on in this session, is that you pretty much have three options with this basic. So availability set. So if you recall, I showed that I've already deployed my virtual machines within availability set. So every virtual machine now or in the future that joins this availability set, they'll be they can be a candidate for to be added to be behind this load balancer. So you also could do a single virtual machine. So if you just want to have it hit one single virtual machine, that's also doable. Or if you're using virtual machine scale set where you're scaling out to hundreds or thousands of systems, you can do that as well. I believe the basic SKU that I'm using is limited to 100 systems, I believe, behind that. But if you're using the standard, I think you can have like 1,000 systems behind the load balancer. So depending on your scale, you may have to use the standard, but it just kind of depends on what you're trying to do. So in my case, it's very small scale, since this is just a sample or a demo of it. So I'm going to go ahead and select availability set. And then once I do that, that'll go and show me my availability sets in my environment. So I do have several availability sets, but for the purpose of this, I want my SCOM SACMS availability set. So the idea here is that I'm adding any SCOM management services that I add to my environment. I'm putting them in availability sets. That does a couple things. So on the Azure side, with no relation to the load balance or anything going on there, is that on the Azure side, when these virtual machines are deployed, by them being an availability set, it will kind of ensure that they'll be deployed to hosts that are on different racks that have different power and things like that. So that whole rack where one of my virtual machines live, like loses power or crashes or whatever happened with that whole rack, I can be ensured that my other virtual machine is should be on a totally different rack with totally different power source and things like that, so it shouldn't be affected and should still be available in the case of if something goes down. There is also a concept in Azure of availability zones, but that's kind of outside the scope of what we're talking here, but that has a little bit more resiliency as far as it's not at the rack level, it's more so at the whole data center level. All right, so we have our availability sets selected, and now we need to add the target IP configuration. So if you're depending on your virtual machine and how many NICs and things like that are configured on it, this will go and enumerate what those IP addresses are on those systems, and then I can add those individual ones. So I got to go ahead and select my target virtual machine. So in my case, this availability group or availability set has 2 virtual machines in it. So I'm going to go ahead and click SCOM-SAC1, and then I need to pick one of the available IP addresses on it. So in this case, it just has 1. So I'm going to go ahead and add that to my backend pool. I'm just going to go and do that same process again for my other virtual machine. So I'm going to do SCOM-SAC2, and then select the IP address. All right, and then go ahead and say OK. I thought I clicked OK, but all right. So saving load balancer backend pool. Maybe I didn't click OK. All right, let's try that again. Let's say OK again. I think I might have did something wrong there. Let's try it again. Not sure if it did anything. Okay, so what just happened there is that uh, there's another limitation that I forgot to mention. So I believe per availability set, you only can have one internal load balancer and one public load balancer. So in my case, I already have a public load balancer associated with this availability set. So when it went to go deploy it, it pretty much bombed out an error. So what we're going to do, we're not going to save this particular thing. We're just going to go back out of it. And what we're going to do, we're going to go ahead and jump over to my HD configure load balancer one. So I'm going to go ahead and jump over to my East Azure Load Balancer public SCOM-SAC, and then we'll go through the rest of the steps that I did when I created this one. So I'm going to go ahead and go to Backend Pools, and you just kind of see what I did there. So essentially, this is configured the exact same way what I just showed on the new load balancer that we created. Just since I already had created that, it wouldn't let me do it again on a different load balancer. All right, so we have the backend pool. So the next step is that you'll go and configure your health probes. And what the health probes are is that you could have the load balancer periodically go and check whatever TCP or UDP port your service that you're trying to load balance use. It'll go and check that on the nodes and see if that's available. And then if it's not available after a certain period of time that you can define, that node will be removed from getting traffic routed to it. Essentially what will happen under the covers. So in my case, I've actually configured 3 different ports. So I've configured HTTP traffic, HTTPS traffic, as well as like SCOM SDK traffic, where I can allow me to connect to the SCOM web console even over the internet in this case. So let's go ahead and take a look at one of those so you can get an idea of what that looks like. So I'm going to get my HTTP. And once you're in here, you essentially will kind of give it a name. You'll go and select the protocol that you're using, if it's going to be TCP or HTTP as far as your probe. So in this case, I just said TCP. Probably could have been HTTP since it really, but yeah, it should work. Port 80 is the port that I selected, and then I'm having that go and check that every 60 seconds essentially. So that's higher than the default value. I think the default value is like 5 seconds or something like that. But for my case, I don't need to check that frequently, so I bumped it up to about 60 seconds. And then you can have some criteria as far as what is the unhealthy threshold for you. If is it 1 consecutive failure, is it 2 consecutive failures? It just depends on what your tolerance is. So in my case, I've said, hey, after 2 consecutive failures every 60 seconds, if the probes are failing, then it'll start removing those nodes out of the rotation essentially. All right. And then for the other 2, essentially the same thing. I just went in and gave it a different name, and then configure the ports that I'm expecting to use, that I want the help probe to go and hit. So the next part is you have these load balancing rules. So let's go ahead and jump over to that section. So in the load balancing rules area, this is where you go and tell it, okay, how do we want to, what traffic do we want to have? So here you see I have very different ones defined again, and I gave them names. So let's go take a look at the SCOM SDK one that I created here. Let's go take a look. So as we look here, we see SCOM SDK, IPv4. So you'll see the IP address defined or associated with that particular workload. You'll see the protocol. So what protocol are you using, TCP or UDP? You define that at that time. And then here you can have, so say if I want my public port to be something different. So say if I wanted to use a alternative port for inbound traffic that's hitting the load balancer, but so for example, I can come in on 5723 from the internet, but then once it hits the load balancer could then direct that to, say, port 5700 or whatever other port my application is using internally. There's no requirement that these ports for the front end and the back end needs to be the same. Simplified, in my case, I kept the front end and back end ports are the same. And then you go and select the backend pool that you're going to be using. So in my case, those two virtual machines that we looked at earlier. And then I can associate a particular health probe with it again. So depending on like these two virtual machines, if they'll be part of the rotation or not, will be based on this health probe that's going to be probing port 5723 internally on those virtual machines. So if they fail 2 times on that probe, they'll get removed from rotation. And then finally here you can do session persistence. So say for example, say the first time you come in, you'll get assigned one of the nodes in the rotation. Do you want to have the load balancer kind of make you kind of sticky to that particular backend server or not? So do you want it to round robin you between whatever is available, or do you just kind of want to have a sticky session? So in my case, I set it to client IP and protocol. So essentially what that means is if I'm coming the first time I come in, as long as the node that I hit initially is available, I will stay stuck to that particular node. Or at least that's the idea behind it. But if that node goes away and it gets removed out of rotation, obviously, then I'll get redirected somewhere else under the covers. It's the idea behind it. But so you can have this at none. Like I said, that'll just kind of round robin you to whatever. But depending on your application, though, that may or may not work, depending on how your actual application works. If it's not really that session specific, then you don't necessarily need to do that. It doesn't matter what node you hit on. That's pretty good for like a public facing website of some type that you don't have to authenticate on or anything like that. That may be a good use case where you don't need to have any type of session persistence. But just kind of want to show you that. And this floating IP direct server return, I've never used that setting, but my understanding of it is that for certain applications, the way that they behave, in particular, I think SQL Server always on, you kind of need to use that setting in that particular use case to make it work properly. But I'm not going to use that. So go ahead and exit out of that. And go over to inbound NAT rules. I'm not using any inbound NAT rules, but that's the case where you can say, okay, for this on this port 9000 that I'm picking at random, right? I can go and have come in and direct me to one specific system on one specific port if I needed to do that using the same load balancer public IP. But in my case, I don't need to do any of that. So at this point, from the perspective of the load balancer, our configuration is done. However, on your virtual machine, it may not work the way you think. So right now, theoretically, if my virtual machine was running, I should be able to go and hit that IP address publicly that's associated with my system and actually access my SCOM server across the internet from anywhere using that public IP address. However, in your environment right now, say if you've been following along as I've been talking, it actually probably will not work. The reason for that is that when you deploy an Azure Virtual Machine, there are network security groups associated with that virtual machine. And more than likely, it does not allow any internet traffic inbound to that system right now. So what happens is that when you try to come inbound and through that load balancer, so the load balancer gets in, it hits your VM, but the source of that original request is actually from the internet. So your network security group will see that and actually will block that traffic. So it'll never reach your box by default. So I'm going to go show you how to fix that so it actually works. So, again, we'll just jump back over to our virtual machines. Give that a little while to load. All right, so then you'll go to the particular virtual machine that you just added or just configured. I'll just use SCOM as an example. I'll go ahead and click on that. Then on my virtual machine, I'm going to go to networking. So in networking, this will be your particular NIC that's associated with your virtual machine. And then that virtual machine has that NIC has a network security group defined on it that gets associated with it at deployment time. So by default, it's normally going to allow VNet inbound traffic. So any other system that's within that same VNet, it actually will allow them to communicate. Same for outbound. As long as you're in that same VNet, it's going to allow you to communicate inbound and outbound, right? And it'll allow outbound internet traffic. So from that box itself, you can actually get out to the internet. But if something from the internet is coming in trying to talk to you, that traffic by default will be blocked. There's a couple things that need to be done. So one will be taken care of for you automatically. So allow Azure Load Balancer inbound. That will kind of show up and be there already for you. The one that I added in for my purposes is I named it allow AOV SCOM, and I specified various different ports. So let me just go through an exercise of what that would look like to configure that. So what you do, you'll click the add inbound port rule button. That'll open up a little wizard here on the right hand side. And for my case, for this basic network load balancer, I'm using a concept of what we call service tags and available in Azure. So I click the drop down for the source and go to service tag. And then it already knows, okay, what internet traffic looks like. So there's a source service tag of internet that I can select. That's actually the one that I want to use. But there's a wide variety of other service tags available for depending on your use cases and where that traffic may be coming from. Yeah, let me go ahead and say service tag internet. And then the source port range. So source port range, I don't really care what that source port range is. I don't really care what the destination is, right? You can be more specific if you want to say, hey, I want to specify X number of IP addresses. So in the case if your VM has various different IP addresses and you want to ensure and restrict that. If someone later reconfigures the network load balancer to use a different IP address on your NIC, you want to ensure that that traffic actually, the load balancer traffic never can actually use that. You can block it at this level. But again, for my case, I don't care. So I don't care what the destination is. I'm going to allow it through. I want it to be allowed through. What I do care about is the destination port ranges. So here's where I define the ports that I want to allow through that traffic that's coming. So as that traffic on port 80, port 443, or 5723 or 5724 originates from the internet, hits my external public load balancer, and then gets directed to my VMs, as long as it's coming from one of those ports that I care about, I want to allow that traffic in. So that's what we're seeing here on the left hand side, where I allow 80, 443, 5723, and 5724 to be allowed in. And then you also can specify the protocol, TCP, UDP, or any. And then you say you want to allow it or deny it. And then you set your priority. So the higher the number, the higher priority that traffic is. So say, for example, if I had some other deny at, say, at 65, I don't know, 64,999 or 64,998, and I happen to give this 64,999, this traffic would be blocked because it's going to hit the deny everything else before. So I just gave it a higher number all the way up to 100, but just keep that in mind. It's kind of how that works there. Then you can give it a description and a name, and then you add that. So that'll take care of that VM. So I would need to do this same process on any VMs that are going to be part of that network security or part of that internal load balancer piece, or the internal VMs I'm using on my public load balancer. Semantics, getting the words confused there, but you'll have to do that on both. Another option could be you could just have a more broader network security group and then apply that to all the VMs in the group. But in my case, each one of my VMs, SAC1 and SAC2, they have a different network security group associated with it. So I have to do that manually on everyone that joins this particular group and add this particular rule and allow that traffic. So now at this point, this is actually should be 100% ready to go. The only other potential issues that I can think of is that, say, on your VM itself, within the OS of the VM, there's some type of local firewall running on it that's not allowing remote traffic to hit these reports, then you may run into trouble as well. So within the VM on the Windows firewall or whatever software-based firewall you may have to open up those ports there as well. But from the perspective of the Azure Load Balancer, as well as from the network security group that's on top of your VMs, it should be 100% ready to go. So yeah, so at that point, you said, for example, say if you're going to go and try to connect to your SCOM server remotely now at this point, you can just go back to your load balancer, see what that IP address is, that public IP address that's been associated with your network, and hit that on the public web from any location, and you should be able to get to the SCOM web console at that point. Hit the that IP address / operation manager, and you should be able to get to the SCOM web console. So I know this has been quite a long video at this point, but hopefully this has been useful. I know I learned a lot of making it, and I will see you in the next one. Thanks for watching.